Hello viewers, welcome to this session. Here we are discussing about what is real valued function, what is real function, and how we will find the domain of the function. The real valued function, first we have learned that f is a function from set A to set B, and we write like this: f such that A mapped on B. That is all the elements of set A correspondence with an element of set B. And when we defined a function, we told that every element of set A must have a correspondence with an unique element of set B. And this function, when it is a function defined, then it is called the real valued function if the codomain, that is B, set of real numbers, or it is a subset of real numbers. And if both A and B are real numbers, that is, all elements real numbers to real numbers defined, then the function is called a real function. Let us see now here what is domain of a function. As it is a real numbers, all if fx is given where x belongs to R, and if we take fx equals to y and x belongs to R and y must belongs to R. But which are real numbers? Fx is defined if it is in the form fx in the form under root nx. Here fx is defined when x is greater than or equals to 0 and n is odd. That means if n is even, it will not be. If x is positive, then only defined. If it is negative, it will be undefined. That is root over, say, -2. It not belongs to real number. So if you put x, suppose the function is fx is equals to x minus 2 and x is less than 2, then it will be negative. So that case fx will be undefined. So now we are taking 3 illustrations. First one, fx equals to x plus 5. For all x belongs to R, fx also belongs to R. There is no case fx is undefined for any value of a real number 6. Therefore, we can say domain of fx is equals to set of real numbers. But second case, it is 1 by x plus 5. It is a reciprocal function of x plus 5. And if x is equals to minus 5, then fx is undefined, because something divided by 0 is undefined. Therefore, what should be the domain? So in this case, we will consider domain of fx is equals to all real numbers except minus 5. You can say like this, it is in second bracket. So R minus Z, it contains single-tailed element, minus 5 is the domain. In the third one, this root over x minus 5, as I told, it is a square root. N is an even number here. So fx is defined when x minus 5 greater than equals to 0. This implies x is greater than equals to 5. So which portion? If I take the number line 0 minus 5, so x should be more than or equals to 5. So in this case, we can write domain of fx is equals to 5 to infinity. So here the close bracket, here the open bracket, because including 5 and up to infinity, all the values satisfy this one. No values less than 5. If you take any value less than 5, that is, say, if I take 2, so if you put 2 here, it will be root over 2 minus 5 is equals to root over minus 2, not belongs to R. So all numbers should be greater than 5. Now we are taking another example. Here the domain of fx, we have taken the form px by qx, and both are rational polynomials. But here, if x is equals to 2, then fx is undefined. Therefore, domain of fx is equals to all real numbers except 2. In the last case, this is again in the form px by qx, but x square is always greater than equals to 0. So x square plus 2 always greater than equals to 2. So that's why the domain, so x square plus 2 never be 0. Therefore, domain of fx is equals to all real numbers. Now we have taken a function where fx equal to root over 4 minus x square. Here also fx is defined when 4 minus x square greater than equals to 0. And we can break up into two factors. So if this is 0, that means 2 minus x greater than equals to 0. So x is less than 2. And for the second one, 2 plus x. From 2 plus x, we can say this is x is greater than minus 2. So domain minus 2 comma 2. So for these values, fx is defined. But if it is 1 by 4 minus x, when x is equal to 2 or minus 2, when x is equals to 2 or x equals to minus 2, fx is undefined. So in this case, domain of fx is equals to open bracket minus 2 comma 2. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.